Good evening. Today we have this second lecture, revision lectures. And in this, if you will see, we are going to be with slope and deflection. Now already I forwarded you 3 videos of conjugate beam method, which will gives you the uh, best way to calculate the values. Otherwise, if you are in position to use Macaulay's method, you can go. We have Castigliano's second theorem. You can go. You can use any method which you can do it. Standard values we should know, because if we are with concentrated load at center, then we have WL cube by 48. If we have UDL, which is throughout this span, then we have 5 by 3 a 5. So we have UDL throughout, then we have 5 upon 348 WL cube upon EI. So likewise, we should know these values, which we have, 5 by 384, 5 by 384 WL cube upon EI. So we should know these standard cases, and that we have to use it. You can go by Macaulay's, you can use conjugate, and you can solve these all problems. If you will see, these are, we have slope and deflection, so that we can do. Now next we should understand it, how to go for. So some problems we have for shear force and bending moment. And now in this case you can see this, we have this bending moment x to the power 2. So we should have loading diagram with x to the power 1. Sorry, x to the power 0 means this is parabola. So we should have UDL over there. And now we have to say which are with UDL. So we have, this is one with UDL, this is another with UDL. Now, so no question of these two. Now we have given that is value maximum over here, and then we should have here, this is bending moment diagram. So we know we should have bending moment at end. If I will consider this, my bending moment is 0, and constant bending moment we should have over here means we should have D. So need not require to calculate the values, that we have to understand, and then we are in position to solve these problems. So now we are with this because we have constant bending moment in this length, and you can have this constant bending moment in this length. Then we have conjugate beam. So already if you have gone through this, so we have in conjugate beam, so this fixed end should be converted. So if we have like this, then fixed end becomes cantilever and simple will remain simple. Means fixed becomes cantilever, cantilever becomes fixed, cantilever becomes fixed, then end simple roller will be as it is, end simple or roller as it is, and continuous internal hinge and internal hinge continuous. Internal hinge continuous. So these conversion you have to keep in mind, continuous support. So now in this you can see we have this as fixed. So fixed becomes cantilever. So we have to see we have only this as cantilever. So we need not require to go other options also, but then also we will see internal hinge. Internal hinge becomes continuous support. So we have this as continuous support. Then we have this as continuous support because we have overhang. This is not end support, and therefore we have internal hinge. And then we have a last fixed cantilever. So we know cantilever becomes fixed. Then we have this as fixed. So likewise, we have to go. If I have to plot a conjugate beam for this, what will happen? So this end simple will remain simple as it is. Internal roller continuous support becomes internal hinge. And this fixed becomes cantilever. Now if we will go for this, then this will be as it is. Then this internal hinge becomes continuous support. Then we have continuous support becomes internal hinge. And fixed becomes cantilever. So likewise, we have to plot this conjugate beam. We have question on this most probably. And then again, we have this also, we have slope and deflection. Then method, you have to decide which method you have to go for this. So same we have over here. Now here we have to find deflection and we know what is formula Castigliano's first theorem. So we have delta that is equal to summation PKL upon A. This is interest. Now what will happen in case of these beams? Then you have to apply unit value. So you can see this here they have mentioned using unit load method, calculate the vertical deflection. So whatever we are using in trusses, same way you have to apply unit value over here. And then you can have these forces, then you can have this. So we have to go serial number. Unit load method means whatever we have Castigliano's method, instead of P, we have to apply over there as unit value, which will get as K. And then we have to analyze it by using delta is equal to, we can go for this formula, M into dabba M by dabba P. Likewise, we have to go there. You are going to be with directly dabba M by dabba P. No, you are M into dabba M by dabba 1. So that is one value we are going to consider and we are going to get values directly over there. And then we will have these values. So now here again, we have given bending moment diagram and then which one is correct one. So now again, you can see this here we have UDL. So UDL we have 1, 2 and 3. Now this is bending moment and then we can have constant value over there. So now we have here no load. So now you can see this will not be there because we do not have this same way we can see, sorry, this will not be there. Now here we can see we have bending moment over here and then from this we have sorry, this will not be there because here we have fixed end moments. So now we have question of 2. So we have this one and this one. Now if we will go for this, so we have this simply supported and in this beam will not go downside. Means I do not have bending moment below the line. That is on one side. It may not be below the line or above the line. And therefore we have answer is this one. So first, this is not there because we do not have UDL. Second, this is not there because we have end support fixed and here we do not have fixed end moment over here. And now this is one beam. So we do not have this diagram because bending moment will be above the line or bending moment will be below the line when concentrated or UDL is there. So remaining we have this and therefore we have option. So you have to see which will satisfy this and that you have to go one by one. Now ILD, this is most important. If I will consider any beam, and we have to go for ILD. So now we have this will be RA, we have this will be RB. And then how we will go? We have simple 1 over here, we have 0 over here. This is ILD for RA. Now if we will plot ILD for RB, what we will get? Then we will have this will be ILD for RB, one value at B, 0 at other RB. Now if I had to find shear force somewhere that is C point, then we have to go below. Now we can use RA or you can use RB. Now we know left of unit load A to C, we have 1 minus RA and 1 minus RA is nothing but RB. So if this we have some distance, then we are going to get 1 minus, it will go down. And then in remaining portion CB, we have this will be ILD as it is. And then we can plot it. That you have to understand. Now in this case also you can see choose the correct. So here we have to go that is shear force. So C till C, if you can plot this. So for RA we are going to be like this. And then for C point. So after here we have total distance we have 20. So at this point we are going to get 6 by 20. Now, in this portion A to C, we have RA minus 1. So we have to 1 minus 1, 0. And then here my value, that will be 6 by 20. So we have 1 minus 6 by 20, 14 by 20. And 14 by 20, we will get 0.7 with minus sign. So we will get this option. 1 minus, sorry, RA minus 1, RA minus 1. And after this, we have this will be RA. So we have this will be RA, this diagram. So that we have to understand, and then we are in position. Here you have to find out, that is choose the correct influence line diagram. Now we have A to C. Now we are going to use ILD of RB only, because that is easy when we can go directly likewise. And then we have to find out at point D. So now unit load A to D, we have RB as it is. So A to D RB as it is, no load. So we have this will be as it is. Now from D to B, we have this value, that is 1 minus RB. And then we do not have anything till this. So we have value 1. And then we have 1 RB over here. So it will reduce and we will get this ILD. Try to understand this. Go through this one. So ILD RA we have plotted. RB we have plotted. And we have to go till D. And then in this portion, my equation will be 1 minus RB, because we have downward positive on right side. And in this portion, I have value that is same 1 minus RB. But here RB 0, so it will be as it is. And on left of this, when unit load is A to D, I have in this portion, I have RB. This portion 1 minus RB. And then it becomes 0, and therefore we have 0 over there. And then in this portion RB 0, so we have this will be D to C1. And then we have 1 minus RB. So if we will take every point, then we have this will be the diagram. Try to understand the diagrams and then go for this. Then here you have to find, that is in each for which ILD is drawn mentioned. For what we have plotted this ILD. First, that is ILD for vertical reaction at B. So how we will get for B? So we are going to be 0 at C, and then we have 1 at B. So we know whenever we are going to find out for RB, RA and RD, we should have 0 values, and we have beam A to C as 1. So we have first this will be, this is 1 and 0. This is at C, not at D. At D to C, we should have this value 0. Then this is given ILD for vertical reaction at A. Not possible, because we know at B, RA should be 1 and we have given this value. So this is not possible. ILD for bending moment at D. So bending moment at D, we have with this ILD. So that is also that we can check it. And then we are going to be bending moment at D, and we are going to consider reaction RB. And then you can go for this unit load. We have to plot, that is from A to C, and then bending moment we have to A to D, and then we have to go for bending moment. And then likewise we have to find out this, and then we will get answer for this. So what we have to go for, that you should be in position to understand. So we do not have this for RB, we do not have this for RA, we do not have now we have this ILD for shear force at C. Now you can see at C, so we are going to be this portion. So now what we will get it, now this is bending moment, we have little bit difficult, we will not go, whichever easy we will go for this one. Now this is C point, so what we will have, so A to C, what will be shear force? So shear force will be minus RB, because we have this will be upward. And therefore we have A to C, unit load A to C minus RB, A to C. And now RB value, we have A to C 0. So we will have this will be as it is with 0 value. Now C to B, C to B. So unit load is on between C to B. What we will get? 1 minus RB. Now you can see at C we have 0. So it will be 1. At B we have RB 0. So 1 minus 1 0. And then it will be this one. So ILD for shear force at C. Then we will have this value. Now if we will find bending moment at D, then you have to go RB into 4. When unit load A to D. And when unit load D to B, then we have RB into 4 minus 1 into X. And then we have to go for this. So try to understand, be very calm while solving problems of ILD. ILD is simple one. So here actually this is difficult one. You have to find total load, position of total load, and then we have one of the load and your total load should be equidistant. So this should be X. And then we have to put this at a center. So this will be 60 and this will be total load. And this should be X by 2, X by 2 from both sides. X by 2, X by 2. So that we have to see. Then ILD is already I mentioned. So that is important one. So if we are like this, then we have to consider only this portion first. So I will plot ILD for this portion. So what I will get ILD for RA, RB. So we have like this. And then you have this slope should be same. So we'll go in this fashion. Now here we have this is one hinge, we have this is another hinge. So A to C we have one beam line should be linear. C to F we have another line linear, and F to B we have third line linear. And we have to choose the correct influence line diagram for vertical reaction at D. So at D. So what will happen if we will take D up? So it will go with one hair. We know value of E should be 0. Value of B should be 0 and value of A should be 0. So try to understand the problem which you have to solve. So we have this will be RD, then we have this will be E, then we have this will be B, then we have internal hinge over here, we have internal hinge over here, and we have this as RA. So now I have to find D. So it will go up with value 1 over here. Value at this is 0, value at this 0, value at this 0. So now we have C to F one beam. So I will plot, I know the 2 points, I will plot it. Now I know value at B 0, I will connect it. Value of A 0, then I will connect it. Then we are going to be diagram in this fashion, and we have this diagram, that is this diagram. So try to understand this and then you solve. ILD is simple. So just you should know. Now suppose you have to go for bending moment, then it is again simple one. So we have for this is A and this is B, then we are going to be AB by L. So AB by L. This is BM ILD for bending moment at C. Now if you have overhang, so simply you have to extend. So this will be extended like this, and this will be extended like this. So for bending moment also it's simple, but very rare they have asked for bending moment. So prepare for reaction, prepare for shear force. So this is all about your second revision lectures, which are related with your assignment number 4, 5, 6, and we will stop here only for this.